right? Amruta, thank you. Amruta, is your question answered yesterday? Amruta? Okay. So the question was why 1 by s is having a slope of minus 20 dB per decade, why s is having a slope of plus 20 dB per decade. So just substitute two frequencies in decade. So in s, if you substitute 10 and 100, then you will be finding the gain will be, or the difference in amplitude will be 20 log 100 minus 20 log 10. So in this case, GSHS equal to s. Okay, so if I give you like that, GSHS equal to s, that means a zero which is occurring at origin. What will be its slope? So that was Amruta's question, and it's a very relevant question. If it is s square, so we say s square is having 40 dB per decade, or maybe s plus 3 whole square. S plus 3 whole square also will be having 40 dB per decade, but starting point will be 3 comma 0. Okay, and if it is s square only, the s square will be starting from uh, minus infinity, will go to plus infinity, and it will plus pass through 1 0 point. So she asked s square, why s square will be having a plus 40 dB. So you substitute s square, two frequencies. So if you substitute 10, you'll be finding s square is equal to 10 square, that is 100. And if you substitute 100, you'll be finding s square is 10,000. So how to find the difference between the amplitude? It is 20 log 10,000 divided by 100. That means 20 log 100. That means it is log 100 is 2, log 10 is 1, log 1 is 0. So if it is a ratio of frequency 100 and 10, it will be 100 square by 10 square. So that will be 100. So log of 100 is equal to 2, 20 log 100 is equal to 40. So s square will be having an upward slope of 40 dB per decade. S cube will be having a upward slope of 60 dB per decade. S, that means all these are zeros I'm talking about, it will be having an upward slope of 20 dB per decade. Same thing happens at the denominator. So 1 by s, that means 20 dB per decade. 1 by s square, that means minus 40 dB per decade. So 1 by s is having minus 20 dB per decade. It is falling slope. 1 by s square minus 40 dB per decade, 1 by s cube minus 60 dB per decade. So all those things yesterday I had shown that document. I had drawn all this in graph paper and I have shown, I have uploaded it. So please check all the lectures and check all the documents which are being uploaded. Again, I'll be giving you a recap. So today we are not going to okay, we will be solving some numerical today. So this is from a book. It is not very prominent, but you can see here. Okay, so this is a similar graph paper. They are saying this left corner as origin, and the right corner, right side is called as log omega. So semilog means x-axis is logarithmic, y-axis is in dB, so it is linear. It is like this. So whenever it is for m, so 20 log k, so they are saying m dB. So k is a constant. So this graph is showing at the top. This graph is showing. This document also I'll be sharing with you today itself. So this is from some book, and a lot of numericals are solved in a book, but it is of no use as long as you are not solving the same numericals by using similar graph paper. So yesterday I have got hold of around 15 similar graph papers. I will start plotting it, and I'll be solving those numericals and I'll be uploading it. But before that, you have to solve this. Okay, so please purchase similar graph paper and solve it. So if it is a constant k, how to draw its Bode plot? So k means 20 log k, that means m dB. So it is a parallel line with respect to 0 dB. Okay, so if k is in between 0 and 1, so k is decimal, at that time m will be negative. So if k is 0.4, in that case we have seen the 20 log of 0.4, it comes around minus 8 or something, it will come below. So here the k is greater than 1, hence it has come above. So this is one thing we have to understand. And whenever it is k, phase of that thing is equal to 0. Okay, 0 degree. So it is 0 degree, it is plotted like this. Then next, all the known things to us, 1 by s raised to k. Okay, if k is equal to 1, then it will be having, it's a single pole, it will be having minus 20 dB per decade. If 1 by s raised to 2, then minus 40 dB per decade, 1 by s raised to 3, minus 60 dB per decade. And why is it so? It is given here. Okay, so all those things are given here. So y is equal to minus 20 log 20k log w. Okay, so 20k means k is the power. So if power is 2, it becomes minus 40. If power is 3, it becomes minus 60, and accordingly. So all the answers whichever I had done yesterday, I am giving you the proof from a book only. Phase plot, 1 by s raised to k. So 1 by s raised to k means it will be minus 90 into k. So if it is 1 by s, that will be having minus 90 degree. इतना याद रखो बस. 1 by s means having phase of minus 90 degree constant. 1 by s square minus 180 degree constant. 1 by s cube minus 270 degree constant. So likewise. So here they are saying GHS. GHS means GSHS. Okay. So 1 by s raised to k. So when k is equal to 1, at that time it will be minus 90. For k is equal to 2, minus 180. So it will be a straight line directly coming to 0. K is equal to 3, it is minus 270 degree and all. So all these things are given. So all this detailed proof you won't have to do. So just see what is given and that much is there. Uh, so there is nothing difficult in this. I'm still in the basics. I'm doing still the basics. All the new things, basic things, whatever are required to plot the graph. So this graph is also known to you. So first graph is 20 dB per decade. This is the fall. This is 1 by j omega. Next graph is 40 dB per decade. It is starting. So this point is 0.1. It is written here at the top. You can find 0.1 comma 40. Okay. And then it is passing through 1 0 and then it is coming to 10 comma minus 40. So this second line is, it is the 1 by s square. So j omega is s. Third line is 60 dB. So this is 1 by s cube. Then it is 1 by s to 4. So in Bode plot drawing in the graph, so first very faintly you can draw these 4 lines. So this is another way of drawing the Bode plot. So whenever you need between 2 points, you need a slope is minus 40 dB per decade. So in the right side of the Bode plots, I will show you exactly these 4 lines you can draw very faintly. Okay, because whenever you are supposed to draw between 2 points, how much is the slope? Suppose 40 dB per decade. You are having a instrument during your engineering drawing thing where you used to match the slope. एक slider जैसा रहता है उसके नीचे. So first you copy a slope and then you slide the slider and you come to that point where you want to draw it and you draw the slope. What is that instrument called? Anybody can tell me? So it was a scale kind of thing in between and there was a ruler at the back. Anybody? You used to use that thing just to copy all the slopes. So exactly that kind of thing. It's a sliding kind of a scale. So that scale you can use to copy all the slopes. Okay, so this kind of thing you can draw at the right side of your journal or right side of your answer sheet. Then you can copy all the slopes. So in that case, you will not have to calculate what is the next point and doing that. So mainly in resultant of Bode plot, you had to copy all the slopes. So all these 3 4 slopes plus one slope is s. So if it is s, it will start from minus 20 dB plus comes to 1 0 and come here. If it is minus, it is s square. That means s square at the 0. That means it will start at minus 40, come to 1 0 and go to 40 comma 10. So likewise, upward slopes also will be there for 0, downward slope for poles. So 0 is at origin or derivative factor. Poles at origin, it is called as integrating factor. That means 1 by s, you can see here. Poles at origin, okay, I have not shown that. Poles and origin are called as integrating factor because 1 by s is a integration. 1 by s square is double integration. 1 by s cube is triple integration. All these things I'm showing here. That means 1 by s or s at poles at origin. Now it is shown that 0 is at origin. So you can see here it is s raised to k. All these lines will be in an upward direction. So the same thing I had shown here in one graph. So you can see here this is s cube. So s cube is giving you 60 dB per decade, s square is giving you 40 dB per decade, s is giving you 20 dB per decade and accordingly. So those are pure poles and zeros which are there at origin. Now I'm giving you a first order pole. So first order pole is 1 plus j omega by p or 1 plus s by 2, the way we have seen yesterday in the corner frequency. So 1 plus s by 2, s is equal to j omega. This is first thing you have to understand, s is equal to j omega. So 1 plus s by 2, how to draw it? Okay, so 1 plus s by 2 will be having a slope of minus 20 dB per decade starting from the point 2 comma 0. The same thing they have drawn. So 1 plus s by 2, how to draw it? Summary of Bode magnitude and phase plot. So this is a summary which is given. Constant gain k, how to draw it? So magnitude and phase, both the things are given. So in your numerical also you can do this kind of table, so that it will be easier for us to understand. So if there are four cases, so yesterday we have seen a numerical, there was zero point 0.4, there was s, there was 1 plus s by 2, and denominator 1 plus s by 3, and all those things. So here all these things you can show here. So this is a way tabular form of solving the Bode plot numerical. So all the basics are kind of done except the second order poles. Okay, now I am actually telling you how to formulate for final exam and how to write it. So one or two numericals we will see how to solve, and then it will be easier for us. So how to draw lines. Now please concentrate, you people, how to draw lines 20 dB, 40 dB, 60 dB per decade at any point. Okay, so I think all of you are there, so please understand this point. You have not known, so I have given you a point called as this point, point A. Okay, so let us go through this numerical. So any point, any slope, you should be able to draw from any point. So how to draw 20 dB per decade line passing through omega is equal to 10 comma 20. First you have to detect what is omega is equal to 10 comma 20. So this point A, this point A is called as 10 comma 20. What is 10? 10 is nothing but frequency. You can see here, this is the 10 frequency, here it is written. And what is 20? 20 is the dB. Okay, so I did not show you all these things yesterday. So this is by similar graph paper, I'm showing it to you now. So A point is 10 comma 20. Now you have to draw a rising slope with a slope of 20 dB per decade. So two things we have to do. First is whatever is 10 here, what is the decade frequency of that? So decade frequency of 10 can be 100. Okay, so decade frequency of 10 is 100, decade frequency of 10 is 1 also. But whenever we are drawing a rising slope, we are going in the right side. So 10 is becoming 100. So what is the next point? So if I give you 2 points, you join that and you can tell me the slope. Now you have to do reverse. I'm asking you, point A is given 1020, that means 10 radian per second, or log of 10 rather, that is the x-axis, and 20 dB is the amplitude. So what is the coordinate of this point A? The point A is having 10 comma 20. 10 is actually log 10 and 20 is 20 dB. What is the next point with 20 dB per decade? So 10 ka decade 100, and this 20 will rise again another 20 dB, so it will become 40 dB. So what is the point B? Point B and point A, if you are joining, this will be having a slope of 20 dB per decade. So first decade, that means 10 will go to 100, so this is the point, and it was whatever the value of dB was here, add 20 with that. So it was already 20, then we have to add another 20 with that, so it will become 40. So what is point B? Point B is 100 comma 40. So that is what they're saying. So this is what you have to understand very clearly. For example, omega is equal to 0.1 radian per second, and that is decade apart. So similarly, omega is equal to 20 radian per second. So it is given here 1020. One 1020 point is given. Now from omega is equal to 10, move to the right side by a decade frequency 100. So from 10 you go to 100. And then at omega is equal to 100, the line will be up because this is given as a 0. Okay, so this is given as a 0 line. So 20 dB more than the initial amplitude. So initial amplitude was 20, now 20 dB add with that. So it will become 20 dB more than 20 dB, so it will become 40 dB. So what is the location of point B? So point B will be 100 comma 40. Point A was 10 comma 20. Point B will be 100 comma 40. So dB per decade. So dB increase will be 20, and decade will be 10 to 100. So that's why point A, if it is 10 comma 20, point B will be 100 comma 40. Now you join this, so whatever line you get here, this line will be called as plus 20 dB per decade. Similarly, if I ask you minus 20 dB per decade, that means that will be a falling line. So this is 10 comma 20, so you come here 100, decade ho gaya, then it was 20, it will fall. So now next point B will be 10 comma 0, oh sorry, 100 comma 0. So what is the next question? Starting from point A, draw a minus 20 dB per decade line. That means the gain will fall. So as here it is 10 comma 20, a line, to draw a line you need at least 2 points. So what will be the next point? 10 ka decade frequency. So 10 ka decade frequency will be 100, and now it is 20 dB, it will be falling, so it will be falling by 20. So initial gain is now 20, now 20 minus 20 will be 0. So what will be the next point? Next point will be 100 comma 0. Now this point is called as point C. So if you join this 1 and C and bring it down, So this whatever slope, that is 100 comma 0, if you do that, it will be giving me a slope of minus 20 dB per decade. Somebody wants minus 40 dB per decade. So in that case, you have to come to 100 comma minus 20. So it was at plus 20 at this point. So plus 20 minus of 40, because at the next level, this point should fall by 40 dB in one decade. So decade means 100. So A to B, it is a decade. And it was at 20, it should fall by another 40 dB. That means it will come to minus 20. So 20 minus of 40 is minus 20. So if you join this A point and this point, so this point is 100 comma minus 20. So this slope will be for 1 by s square. So 1 by s square is having minus 40 dB per decade slope. So joining A and this point, which is called as 100 comma minus 20, it will be giving you minus 40 dB per decade. This is a very important thing. Many of the students are leaving, I can see, but please take care. This is another thing, point A. So point A is given as the same. So here the point A is given how much? So let's see what is the numerical. So point A is given as 1,4 dB. Okay, so not necessarily every time it will be 20 or 40 or something. So it is 1,4. Okay, so this is one frequency you can see here. This is frequency 1. So A is 1,4. Okay, so what will be the next point? 1 का हो जाएगा 10 और 4 का हो जाएगा. We want a 40 dB plus decade. So with 4 you have to add 40. Okay, so 1,4, we want a 40 dB per decade slope upward. So 1 will become 10 and 40 will be, and 4 will become 44. So next point will be 10 comma 44. So 1 comma 10 is given. I want a 40 dB per decade from there. So 1 will become 10 and 4 will become 4 plus 40, that is 44. So what is the B point now? B point is 10 comma 44. So 1 4 and 10 44, if you join and extend, in that case it will be a 40 dB per decade line. But why have they stopped in 5? That is the question. Why have they stopped in 5? Sometimes what happens is, suppose I want a 40 dB while you are filing the resultant. Suppose here a 20 dB per decade is getting added and you are drawing it. So while drawing you have to plot this point B, but you have to come up to 5 because maybe at 5 there is another 0. Okay, that means there will be a slope change. So between A and B, there is coming another slope change at point C, which is the at 5 radian per second. So don't draw it full, draw it up to 5. Okay, because 5 there might be another change of slope. Okay, so that's why this is a line 40 dB per decade line, but not extended up to point B, not extended up to point B, because in between at 5 also there will come a break. That's why, what is the question? If you see, you will understand. So draw a 40 dB per decade line passing through omega is equal to 1,4 till omega is equal to 5. So omega is equal to 1,4. What will be its 40 dB per decade point? 1 will go to 10 and 4 will go to 44. So 1,4 का point है 10, 44, but you won't have to go up to 10, 44. You know that the trend will go up to 10, 44, but you are asked to stop at 5. Okay, so you have stopped up to 5. So you are finding that at 5 the amplitude is around, so this is the point at 5, so the amplitude is around, so this is 2444, so this amplitude is almost 32. That means at A, if you are starting at 1,4 and if it is going upward, and while going, when it crosses the frequency 5 radian per second, in that case it will be attaining an amplitude of 32 dB. If it goes up to 10, then it will be attaining amplitude of 4 plus 40, that is 44. But we are asking you to stop at 5, because maybe 5 there will get added something else. So there is another component at 5. That's what I'm just teaching you the steps, that how to draw a slope starting from some point up to some point, but don't go up to that point, stop in between. So that's why the question is, starting from A 1,4, draw a 40 dB per decade line, but stop at frequency omega is equal to 5. So that's why they have first plotted point B. So A is 1,4, B is 10, 44, but they have stopped up to radian is equal to 5. Okay. And we are finding that at 5 the amplitude is around 32 dB per decade. So what is this point now? This point is 5, 32. Okay, so this point in between, wherever I have asked you to stop, I have asked you to stop at 5, 32. Can anybody tell me if I want a minus 20 dB per decade slope here? Okay, so this is not a part of this numerical, whatever is solved. Draw a slope at any point. Okay, this is the point. This is the understanding. ये बच्चे लोगों को समझता नहीं है. That's why they cannot draw the Bode plot. It is not at all difficult. So 5,32 this point. What will be its minus 20 dB per decade line? So very important thing I'm telling all of you, please concentrate. This is a point 5,32. Okay, you can take any point. 5,32 is one point. I'm asking you to draw a minus 20 dB per decade line from 5,32. So what you have to do is 5 ka decade by 50 and 32 will be reduced by 20 dB. That means 32 minus 20, that will become 12. So what is the next point? Next point will be 5 ka 50. So you come here, okay, 5 ka 50, and then you have to drop by 20 dB. So drop by 20 dB means 32 will come to 12. So 12 is somewhere here. So you just connect here. So finding that point is very important. So I'm telling you, last time I'm telling 5,32 is a point, which is this point. Okay, draw a minus 20 dB per decade line starting from 5,32. So then you have to find the next point. Okay, and if you join that point with 5,32, it will be giving you a minus 20 dB per decade. So first you have to see 5,32. What is the decade frequency of 5? It is 50. And 32 से 20 dB तुमको नीचे आना है. And if you come down below 20 dB from the 32 dB point, you will come to the magnitude of 12 dB. So if we are drawing a line with minus 20 dB per decade slope starting from this point, which is 5,32 dB, next point will be 50, 12 dB plus 12 dB. Okay. So this is that point will come somewhere here. So this is 50 line and plus 12 will come somewhere here. So if you just connect these 2 points, this line will be 50 plus 12. Okay. So these 2 point joining, so here 532 then 50 12, if you join, you'll be getting minus 20 dB per decade line drawn from starting point 532. So this is the whole art. The art is to draw any slope, positive slope, negative slope, plus 20 dB, minus 20 dB per decade or anything from the given point. Next we will see how to draw the minus 40 dB per decade line from a given point. So now the given point is omega is equal to 3, and at omega is equal to 3 the amplitude is given as around 10 dB. Okay, so this point A, this is actually having a coordinate of 3, 10. That means log 3 is the x-axis point, which is represented by 3, and y-axis amplitude is 10 dB. Now we are supposed to draw, as the question is given, we have to draw a minus 40 dB per decade line starting from here, but we won't have to go all the way. So 3 is given means its decade frequency will be 30, and here it is 10 dB. So we have to fall by 40 dB. So if you're starting from 10 and if you're falling by 40, then you will be coming to 10 minus 40, that is minus 30 dB. So you're finding here this point is, so for 310 we have to come to 30 and minus 30. Okay, so this point B is actually having coordinate of 30 minus 30 dB. And if you are joining this 310 with 30 minus 30, then whatever line we are getting, this is called as a minus 40 dB per decade line starting from the point 310. But we won't have to come all the way up to 30 minus 30, because it is said that draw a line between 3 to 5. Okay, so we have to start at 3 and we have to follow the slope, but we have to stop at 5, because at 5 maybe something else is happening in the Bode plot. So here we are showing only one graph, only one slope, but something else might be happening at 5. That's why we have to stop at 5. So this is the question. So from 310 we have to join the line hypothetically, that is 30 minus 30, and we have to stop at 5. So at 5 you are finding is this is kind of a gain crossover line. So this 5 you are finding that this point is 50. Okay, this is touching exactly 0 axis. So by luck we have found that gain crossover is at 5 radians per second. So here this point 5, 0. So this is something which I wanted to tell you. So the process is explained in the next page. It is saying that move to the next decade, omega is equal to 30. So 3 is given, we have to go to 30. and says the line is having slope, or the line we are going to draw is having slope of minus 40 dB per decade, we go down 40 dB from existing dB. So at point 3 the dB is 10, so we have to go to minus 30 dB. So next point is 30 comma minus 30. So join omega is omega 310 with omega 30 comma minus 30, but we won't have to go to 30 frequency up to, we have to draw up to omega is equal to 5. So we have to follow the trend. So from 310, whatever is the trend of 30 comma minus 30, we have to follow the same trend, but you have to stop at 5 radian per second. So make sure you have followed how to draw the slopes before you start solving examples. So any given point and any given slope you should be able to draw. So dB per decade, dB per decade. So first we have to decade any frequency x 5 suppose given. What is the decade frequency? 50. So next x is 50, and we have to see whether it is plus 20 dB or minus 20 dB. So if xy point is given, so how to draw the dB per decade? So x, you have to find what is 10x point frequency, and whatever is y is there, if it is asked to draw a plus 20 dB per decade line, so you have to find next y as y plus 20. So in that case your next point will be 10x comma y plus 20. If they're asking you from xy, draw a point with minus 20 dB per decade slope. So in that case, what will be the next point? It will be 10x comma y minus 20. So these two logic you have to remember. So xy is given, xy is the given point. From there you have to draw plus 20 dB per decade line. So what will be the next point? 10x comma y plus 20. That will be the next point. And if they're asking you from xy, draw a line which is minus 20 dB per decade slope starting from xy. So what will be your next point? It will be 10x comma y minus 20. If they ask plus 40, then next point will be 10x comma y plus 40. If they ask draw a line with minus 40 dB per decade from xy, so next point will be 10x comma y minus 40. Here some of the lines are shown which are given having, so these are all pole lines because they are all falling slope, and the right side you are finding all are rising lines, so they are referred to you. So this kind of line, so this is 80 dB per decade, 60 dB per decade, 40 dB per decade, 20 dB per decade, all negative. Okay, so these are 1 by s raised to 4, 1 by s cube, 1 by s square, 1 by s. The slopes you have drawn in one place in your Bode plot, and these are the four slopes. This is 20 dB per decade, 40 dB per decade, 60 dB per decade, and 80 dB per decade. So these are the 8 lines. As soon as you get into control system exam, okay, you take a Bode plot and you can draw these 8 lines. Okay, and from whichever point you want what kind of slope, just iska parallel mein slider leke jao and just take the slope and draw it at that point. So this is one of the easiest way, kind of a mechanical way of drawing the slopes. And what is by actual way? Understanding. So every point you are coming, then count the next point with whichever slope, plot that point and join it. Okay, so this is copying a slope is a mechanical way of doing thing, and knowing the point and plotting it and then joining, that is more technical way of doing it. So now we will go for solved example. Okay, so solved example 160 divided by s plus 2 s plus 20. Anybody having any doubt up till now? You can ask, because now I'll be solving numerical only. How to solve we will see. Anybody having any doubt up till now, you can ask me. Okay, so it is 160 divided by s plus 2. No doubt, sir. Be Mohit. Thank you. So 160 divided by s plus 2 s plus 20. So first thing, what is the first thing? I have to convert this thing into time constant form. What is the time constant form? So from below, from s plus 2. So observation is the key. Be very observant. वो step कहाँ पे mistake होता है, क्या होता है, that every time I tell you. So student ये देखते हैं directly they do 20 log 160. Sorry, that is a wrong step. First, what you have to do is whatever pole and zero is given. In this case, there is no zero. Okay, only pole is there. So you can find here 1 by s plus 2. So if I ask you how much will be the maximum angle, so I give this and I ask you, will this Bode plot, phase plot, amplitude plot, we will come later, but will the phase plot cross minus 180 degree line? Answer is no. Okay, this you have to understand, because 1 by s, this can give you maximum phase at minus 90. 1 by s plus 20 can give you maximum phase as minus 90. So at s is equal to infinity, minus 90, minus 90, maximum phase you can get as minus 180. So never this Bode plot, I'm sorry, never this Bode plot will cross minus 180 line and come below, because maximum frequency omega is equal to infinity. This function GSHS, or only GS they have given, that means H is equal to 1. This is understandable. Okay, so GHS, don't worry about that. So maximum phase it can produce is minus 180 degree. This is you have to take. That means if there is no omega PC, what is omega PC? It is called phase crossover frequency. Every time I'm relating, so this way it is not given in the book, because I'm trying to give you the final fundamental from the beginning itself. Okay, so that you can understand कि क्यों कर रहे हैं हम लोग, because we are trying to find what is omega GC, gain crossover frequency, when the gain initially is high or low, maybe at certain point gain is crossing from the unstable state and crossing the zero line and falling in the stable state. So that is called as omega GC, gain crossover frequency. And what is omega PC? Omega PC is called as phase crossover frequency, at which the phase is greater than minus 180, that means minus 130, minus 140, minus 150, and then phase is falling. At a certain frequency, it is crossing the minus 180 and going into below minus 180. So that point where the phase is touching the minus 180 degree phase, it is called as omega PC, phase crossover frequency, and that is actually a point of instability. That is a phase instability. But in this case, we are finding that S plus 2 and S plus 20 both are poles, and each of them gives minus 90, minus 90 maximum phase when omega is infinity, omega input frequency, which we give from signal generator. So never this thing will cross minus 180 and go to negative. Never it will happen. That means omega PC does not exist. When omega PC does not exist, you have to write that gain margin is infinity. ये एकदम आखिरी में पढ़ाते हैं, but अभी से मैं बता रहा हूँ. Whenever omega PC is not there, why omega PC not there? Because maximum phase is minus 180, so there is nowhere in the whole phase plot it will cross minus 180 and go below. जाता ही नहीं है. So this Bode plot will give us that the phase plot will never cross minus 180 and go below. Hence, omega PC does not exist. If omega PC does not exist, gain margin is positive infinity. For stability, we want positive gain margin. For stability, we want positive phase margin. ये पूरा Bode plot हम लोग उसी के लिए कर रहे हैं. We want a positive gain margin. We want a positive phase margin. So now your system becomes 50% positive, because phase wise your system is already positive, because there is no omega PC. As omega PC is not there, gain margin is plus infinity. That means you can keep any gain in the system, and system will behave like a stable system from phase point of view. Now from gain point of view, we have to check what is omega GC and what is gain crossover frequency. For that, we need to find what is the resultant amplitude plot. Okay, so just check that it was 160. So from here they have taken 2 common. So both the things I have to show you together. Okay, so this is S plus 2. So 2 you take outside, and from here 20 take outside. So 2 and 20 they will get multiplied. So numerator will become 4. So don't start with this whatever is given. Okay, this is 160. Don't make whatever you are doing, that is a Bode plot, from here. Okay, so Bode plot has to be made from 160 divided by 2 into 20. That means numerator will become 4. Okay, so numerator has become 4 now, and now it is in the time constant form. So convert the given transfer function in the standard time constant form. This is the very first step. I am finding many students have not joined it, not joined the session. Many students are leaving in between. But I'm telling you, this Bode plot is not for control system. Bode plot is for any circuit simulation or any system, and not only it is restricted to electrical system. It is restricted. It is applicable to mechanical and any other system. So this is frequency response analysis. You do signals and systems. सब पढ़ते हो Laplace, Laplace ये वो Z समझता नहीं है, Fourier समझता नहीं है. That means you don't understand anything of signals and systems, because all these fundamentals, whatever you understand in Laplace, Z, and all these things, they are applied in Fourier. So Fourier, understanding the Fourier series, Fourier transform, that is the real essence of signals and systems. Samely, whatever we have studied up till now, Bode plot is actually the culmination of everything. So पूरा सब कुछ पढ़ के आके तुम अगर Bode plot ही छोड़ दिए, means तुम्हारा control system गया. So that's why we have to give some time. You don't attempt it in the exam, doesn't matter, but at least समझ लो क्या होता है. Okay, so I have converted into time constant form. 4 divided by 1 plus s by 2, 1 plus s by 20. Now you convert. Now you will be finding there are 3 plots. One plot will be a parallel line, that is 4, so 20 log of 4, so 20 log of 4 is 12 dB. Another thing will start from 2 comma 0, and this is a pole, so it will be minus 20 dB per decade. So 2 comma 0, and what will be the next point? 20 comma minus 20. This is starting from 20 comma 0, so 2 and 20, they are the corner frequencies. So you have to draw two lines. One is starting from 2 comma 0 and having a slope of minus 20 dB per decade. Another is starting from 20 comma 0 and having a slope of minus 20 dB per decade. And I told you how to draw it. Okay, so now all the separate things they are showing here. So this is the plus 12 dB line. So 20 log k, 20 log k means 20 log 4, that is 12 dB. ये तीन लाइन भी ड्रॉ करो, so out of 10 you are given 4 to 5 marks, that is there. And phase plot तो easy है. Only students cannot understand the resultant. So resultant में 2 marks रहते हैं, 2 to 3 marks रहते हैं. And if you are not drawing the resultant correctly, you will not be able to talk about gain margin and phase margin, because for that resultant is very much important. So if you just draw this 3-4 lines whichever you are getting from time constant form, and if you can draw the phase plot, so at least 5 to 6 marks you get. Okay, and resultant is not difficult. Again, I'm telling you, resultant is not difficult. Only thing, basic things you have to understand. So you are now plotting 1 plus s by 2. So this is that 1 plus s by 2. It is starting from 2 comma 0. So first line is 1 plus s by 2. This is a pole line. And second is 1 plus s by 20. So first line is actually the constant line 12 dB. ये ऐसा हो गया. And then 2 comma 0 and 20 comma 0. You have to plot two lines. So you have started plotting from 2 comma 0. So what will be its falling point, which is falling by 20 dB. So 2 ka decade at 20 and 0 will go to minus 20. So you have to plot this point first, 20 comma minus 20. What is this point? If you are joining 2 comma 0 with 20 comma minus 20 and extending it, this line will go to minus 20 dB per decade line, starting from 2 comma 0. Another line you have to draw from 20 comma 0 with the same slope, minus 20 dB per decade. So this point is 20 comma 0. What will be its 20 dB per decade negative? So 20 will go to 200. So this is a 200 point. See here it is 100. So this is 100 means this 2 is 200, this 3 is 300. So next point will be 200 comma minus 20. So this point is actually 200 comma minus 20. So for 20 comma 0 it is for 2 comma 0 it was 20 comma minus 20, and for 20 comma 0 it is 200 comma minus 20. So you extend it, join and extend. So this is 1 by 1 plus s by 20 line, and this is 1 plus 1 divided by 1 plus s by 2 line. Now you have to add these three. So drawing individual factors. So this graph is called as drawing individual factors. And what I want you to do is you have to draw all these three things very faint. Okay, I had shown you my total complete numerical yesterday. So you have to draw this thing very faint. Next you have to add. Next you have to add these three plots. So what are the plots? So from 0 to 2, you will be finding the resultant will be same. It will be 20 dB. And then here, what is this point? So this point is 2 comma 12. Okay, you have to understand this point is 2 comma 12. Whatever is up. So whenever you are doing resultant, see what is the resultant. So we are adding it. So whenever you are doing it, just check from 0.1 up to 2. Okay, so from 0.1 up to 2, it will be coming like this. Okay, and this is not the resultant. Actually, resultant comes below, I think. Yeah, this is the resultant. Okay, so this is the resultant. What's happening is from 0 comma from 0.1 comma 2. So this is the same thing. That is the 4 or 12 dB. So this is coming here. Okay, so what is this point now? This point is amplitude is 4 dB, or amplitude is 12 dB. I'm sorry, amplitude is 12 dB, and this is 2 comma 12. Okay, so this point is 2 comma 12. Now what you are finding is that 2 comma 0, there is coming a slope of minus 20 dB per decade. That means you have to draw a line minus 20 dB per decade starting from the point 2 comma 12. Okay, so from 0.1 to 2, there was only one amplitude, that was plus 12 dB parallel. So up till 0.1 comma 2, it has come. So resultant is only one line. Okay, at 2 there are two vectors. Which are the two vectors? One is this plus 12 dB, another is minus 20 dB per decade. So if you're adding it, that means initially it was starting from 2 comma 0, it will go up by 12 dB. So now this point is 2 comma 12, and from 2 comma 12 you have to draw 20 dB per decade line negative, and you have to extend it up to 20. What's happening at 20? At 20, another minus 20 dB per decade is getting added. That means ahead of 20, this slope will become minus 40 dB per decade. So at least first thing we can draw, that is at point 2 comma 12, we have to draw a line which is minus 20 dB per decade. So 2 will go to 20 and 12 will become 12 minus 20, that is minus 8. Okay, so that means this point will be 20 comma minus 8. You can check here. So this height is actually minus 8. This is 0 and this is actually minus 8 because two small regions. So this point is actually 20 comma minus 8 and you have to draw like this. Now question is why up to 20 radian? Because at 20 radian another minus 20 dB per decade is getting added. Okay, that's why you have to draw this line and you cannot extend it up to infinity because at 20 radian something else is happening. Okay, so that's why drawing this line is the main trick. You are starting from 2 comma 12 and you have to draw minus 20 dB per decade line. So 2 ka ho jayega 20 and 12 will become 12 minus 20, that is minus 8. So this point is 20 comma minus 8. So you just draw it. So now you are at 20 comma minus 8 and what's happening at 20 comma 0, another slope of minus 20 dB per decade is getting added to it. So initial slope was minus 20. Now starting from this 20 comma minus 8, the slope will become minus 40 dB per decade. So the question is again drawing a minus 40 dB per decade slope from a point. What is that point? It is 20 comma minus 8. So 20 का हो जाएगा 200. Okay, so 20 का decade हो जाएगा 200 and minus 8 minus 40 because the slope should be 40 dB less than whatever was here. So here the point was 20 comma minus 8. So next point will be 200 comma minus 48. So you can find here this line is 40 and uske niche or 8 dB. Okay, so this point was whatever this point was 2 comma minus 8 and next point will be 20 because 2 ka ho jata hai 20. Sorry, this point was 20 comma minus 8 and this will become 200. So 20 comma minus 8 will become 200 comma minus 48. So that is this line. So now if you add this, so this slope you have to write here, this slope is minus 40 dB per decade. This slope will be minus 20 dB per decade. So what I suggest you, all of you, those who are listening, ये 3 point note करो. Okay, starting from point 1 comma plus 12. So 4 point note करो. I'm giving you time, so please bring pen and ये 4 point note करो. And you have to draw whether you have understood it or not. So first point is point 1 comma 12. इसमें कोई dispute नहीं है because initially the whole graph is starting only with the constant. Okay, so 4 is there, 20 log 4 is 12. So it is coming up to 2. Why up to 2? Because at 2 there is coming a negative minus 20 dB per decade slope. So what is this first corner point? This point is 2 comma 12. So this is one thing you note. There is a second thing. So first point was point 1 comma 12. Second point is 2 comma 12. Okay. Third point is you are drawing a minus 20 dB per decade from 2 comma 12. So what is the third point? It is 20 comma minus 8. This third point is 20 comma minus 8. And because I'm telling you all this point because so that you can do the reasoning and you can draw this resultant on your own. ये एक numerical समझ लो. All the numericals are in the same line. So first point is 0.1 comma 0. Sorry, 0.1 comma 12. Second point is 2 comma 12. Third point is 20 comma minus 8. And fourth point is 200 comma minus 48. So this point is 200 comma minus 48. And it will be extended up to infinity so that this will go. So what are the main 4 critical points? First point is 0.1 comma 12. Second point is 2 comma 12. Third point is 20 comma minus 8. And fourth point is 200 comma minus 48. If you join this, amplitude resultant is done. What they have done here initially, they have not joined that 20 log 4. They have not joined the 12 dB line here. So first they have drawn the just added the slopes. Okay, so starting from 2 it's a 20 dB per decade, starting from 20 it's a 40 dB per decade. Whatever they have got, now they have given it a shift. Okay, DC shift of 12 dB. So the whole thing they have given a DC shift of 12 dB. So this is also another process. First join all the slopes, positive negative, you add all them first, and finally you give it a positive shift if the DC gain is positive, or give it a negative shift if the DC gain is negative. That is another way of drawing the Bode plot. Whichever you like, you do that. So all these documents will be given to you. Please follow to this. Next is how to find the phase plot. So for this numerical, they have not shown the phase plot. You can very easily find out. So what will be the phase of this system? So that is one job I'm leaving up to you. So the phase of the system will be minus tan inverse. Okay, the phase of the system will be minus tan inverse of omega by 2 minus tan inverse of omega by 20. So the phase will become for this. So for 4 phases 0 for this j omega by 2 and j omega by 20. So net phase will be minus tan inverse omega by 2 minus tan inverse omega by 40. So you can substitute the omega as 0.1, 1, 10, 100, 500, 1000, 10,000. Again, I'll repeat you substitute omega as and find all the angle in degree. इसमें radian नहीं है कुछ. Okay. So substitute omega as 0.1, 1, 10, 100, 500, 1000, 10,000. So for all this, whenever you are substituting 1000 or 10,000, you'll be finding that angle of j omega will become very close to minus 180 degree. And then you can plot the phase plot, and you can find out what is the gain crossover frequency. So that is one thing we can find out from this resultant plot. Okay. So can anybody tell me how much is the gain crossover frequency from this plot, whatever is shown to you? Okay, so I'll make it big. Let me just see whether you have understood it or not. So this is a resultant plot. Resultant plot is given below. So resultant plot, what is the gain frequency? Can anybody tell me? Okay, from positive and coming to the negative. So how is the gain crossover frequency? It's in between 8 and 9. So can anybody say it's between 8 and 9? So how much is the gain crossover frequency? Can anybody tell me? This point, this very point, okay, this very point is called as gain crossover frequency. How much is that? Hello? How much is that gain crossover frequency? Anybody?
8.5.
Around 8 radian per second. Okay, so around 8 radian per second. So whenever you are finding a phase, put this 8 in the this thing, finding angle. Okay, so just put this 8 in the angle and find. Can anybody just calculate it? Can anybody calculate it? Just write down this equation: minus tan inverse omega by 2
Sir,
minus tan
presentation
inverse omega by 20. Pardon? Hello? Anybody said anything? Presentation is not visible. Okay, that is possible. So anybody calculate this thing. That is minus tan inverse omega by 2 and minus tan inverse omega by 20. And in case of omega, substitute in case of omega, substitute 8 and tell me how much is the angle. So minus tan inverse omega by 2 minus tan inverse omega by 20 and substitute omega is equal to 8 and tell me how much is the angle. Now presentation is visible.
Yes, sir.
Can you just tell me how much is the angle?
Minus
minus
1.325.
1.3 is little less. I think you are in radian, so please convert into degree. Minus tan inverse omega by 2 minus tan inverse omega by 20. Substitute omega is equal to 8. 8 कहाँ से आया? Because 8 is the gain crossover frequency omega GC that we have found out from the plot. And whatever you find out here, anybody?
Minus 75.96.
Anybody seconds that? Minus 75 point something. Equation is minus tan inverse minus. Yes. दोनों एंगल कहां से आ गया? एक ही एंगल आने वाला है. जस्ट एड इट. माइनस tan इनवर्स ओमेगा बाई 2 माइनस tan इनवर्स ओमेगा बाई 20. ये एक इक्वेशन है. इसमें ओमेगा इज इक्वल टू 8 सब्स्टिट्यूट करो एंड टेल मी व्हाट इज द एंगल इन डिग्री. minus 97.76. Yeah, thank you. Everybody agrees to this? minus 790. चलो minus 98 पकड़ लो. तो ये लिख के रखो minus 98. So how much is gain margin? Gain margin is 82 degree. समझ में आ रहा है? तो लिख के रखो that at gain crossover frequencies, which is not calculated here. Okay, so phase plot, if you do, you'll be finding that. So in phase plot, you insert, because before going for the phase plot, you are first calculating what is the gain plot, resultant gain plot. So from the resultant gain plot, you are finding what is the gain crossover frequency. तो दो चीज लिखो, one is omega gc. Omega gc is 8 radian per second. So before 8 radian per second, this system is unstable magnitude wise. After 8 radian per second input frequency, what is 8 radian per second? 8 radian per second is the input frequency. So when input frequency is less, before 8 radian per second, the system is unstable because gain is greater than 0 dB. At 8 radian per second, what happens? It is critically stable. Greater than input frequency 8 radian per second, system becomes stable. So what is 8 radian per second called? It is called as omega GC, gain crossover frequency. लिख के रखो. And we are finding, write down, we are finding at omega GC 8 radian per second, the is tan inverse omega by 2 minus tan inverse equal to minus 98 degree. Okay, so at omega GC, phase is minus 98 degree, which is 82 degree above, which is 82 degree above minus 180 degree. Minus 180 degree is the phase unstable line. Okay, so at omega GC, we are finding phase as minus 98 degree, which is 82 degree above, or which is plus 82 degree compared to minus 180 degree. Full stop, last line. Phase margin. Phase margin at omega GC 8 radian per second is equal to plus 82 degree. Phase margin at omega GC stands for gain crossover. Phase margin for at omega GC, which is called as gain crossover, is equal to 82 degree. 82 कहाँ से आया? Minus 180 minus 98. That means minus of 180 plus 98. So or 9, so just subtract karo and it is positive actually. Minus 98 is above than minus 180. And how much above? 82 degree. So how much is the gain margin? Phase margin? Phase margin is positive. That is very important. Phase margin should be positive. That means at gain crossover, the system phase should be a lot greater than minus 180. And here it is 82 degree above than minus 180 degree. So positive gain margin means system is stable. So this is one thing you have found from this resultant plot. If you draw phase plot, okay, so from gain plot, what you have found is phase margin is plus 82 degree. Phase margin is positive. Positive होना जरूरी है. Value जितना बड़ा है उतना अच्छा, but positive होना जरूरी है. Second thing, just I will tell this statement and I'll conclude. Second thing, after phase plot, so you have to draw the phase plot the way you have found for 8 radian per second, the same way you have to find for 0.1, 1, 10, 100, 1000, 10,000. Okay, and you will be finding that at 10,000, it will be very close to minus 180, but it will not touch minus 180. It will touch minus 180 and omega is equal to infinity. Last line you can write down that omega PC not exist. It does not exist. That means phase crossover frequency does not exist. That means system phase does not go below minus 180. So phase crossover does not exist. That means system phase does not go below minus 180 degree line. That means system phase is always stable. System phase is always stable because phase always is above minus 180 line. System phase is always stable. That means gain margin is plus infinity. Okay, gain margin is plus infinity because omega PC does not exist. That means gain margin is plus infinity. So here you are finding gain margin is also positive. Phase margin plus 82 degree also positive. So last line, as gain margin and phase margin both are positive, system is perfectly stable. So as the gain margin and phase margin both are positive, system is perfectly stable and stable between frequency of 8 radian per second and infinity. So before 8 radian per second, system is unstable because gain you are finding greater than 0 dB. But ahead of 8 radian per second, system is perfectly stable.